I think this one is going to be our first package. Numpy is a very powerful package. It's the core library for scientific computing in Python. Many other packages are basically built on top of Numpy, such as Pandas. Pandas is built on top of Numpy. And Numpy can create an array object. Array is basically like a Python list, but it's more efficient and uses much less space. And there are many very useful built-in functions and methods for the arrays. To start, if you haven't installed Numpy, please do now. If you are using Jupyter Notebook, you can just right here, conda install Numpy, then it will take like 1 minute or two, and then we can import Numpy as NP. That's the custom. First, let's see how to create arrays. The easiest way is to create an array using a NumPy function called NumPy array. It can convert NumPy list into, Python list into NumPy array. For example, here, we learned from last time that we can create a list in this way. This is a Python list. If we want to convert this into NumPy array, we can do NumPy array. Voila, we have NumPy array. And if we check the type of this array, we can get NumPy ND array. And to get to the a certain element of the array, we can use the same way, similar way as a list. We can use the bracket, say the first element of this array. Sorry. It's 0. So the second one. And if we want to show like the whole array, we can use ... or we can just use this. If we want to check the shape of this array, we can use the built-in method called shape. It will return the shape of this array. This one is a 1D array, so it only has 10. That's the number of elements in this array. Okay, let's go on. And rank. Rank is the number of dimensions of the array. See, if it's a 1D array, the rank is 1. If it's a 2D array, then the rank is 2. Let's create a 2D array now. We can do it like this, create a list first, and then convert that into an array. But there are easier ways, like NumPy arrange. It will return a 1D array. If we want to specify the range of this array, we can 5 to 10, and the step is 2. And this is a very useful way to create an array for testing. Reshape. So this is a method that you can change the shape of an array For example, this one we have this is too large. 20, and let's create an array with 20 elements in it, and reshape it into, let's say, 4 by 5. It's much easier this way. And if we want to show access to a certain element, let's say, so this shows the element on the first row and second column. Yeah, basically, if you are using a list, you want to access to the certain element, it's a little bit more complex. You need to, if it's a 2D array, if it's a 2D list, you need to access to the first layer of that list, then to the next. For example, but using Numpy array, you can. It's like a coordinate. The first row and the first column, first row, second column. Oh, sorry. So in this array, it's 2 by 3, and we want to access to the first element. We use B00. We want access to 2. We use B01. And we want access to 4. We use B10. Yeah. There are other ways to create arrays. Numpy 0 is a function that can create an array with all zeros. You need to specify the shape of the array you want. So for example, I want to create a 2 by 2 array with all zeros. Just need to type in Numpy zeros and pass in a tuple. And for 2 by 3, and Numpy ones, this function will create an array with all ones. And Numpy 4, it can create an array with a constant value, meaning every element in that array will have the same value. We need to specify the value of this constant. So first one is shape, the tuple here. 2 by 2, we can change that to 2 by 3, then change the value. And we create an array of 2 by 3 with all the values is 5. Numpy I, this function will create a Numpy array. It's identity matrix, so all the values on the diagonal will be 1. For this function, you just need to specify the, it's gonna be you just need to specify one number. So if we change to 5, it creates a 5 by 5 matrix. And random, this function can create an array with random numbers, with random values, ranging from 0 to 1. So for example, if we use this one here to create a 2 by 3 array. There we go. And we can also create an array with the random integers. So rand int. For this one, we need to specify the lower boundary, the high boundary, and the size. So, for example, here, we want to create a random array, and the lower boundary is 5, and the high boundary is 15, and the size is 5. There you go. And if you want to create an array with 2-dimensional, then I suggest to use reshape. Two by 5. And there you go. We have a 2x5 array with the random integers from 5 to 15. And we can also create an array with a random number draw from, say, a normal distribution. It will be random dot rand n. Say, passing the shape of the array 2x5. Oh. What's wrong?
No brackets, just 2 and 5.
Okay. And you get the array with the random value drawn from standard distribution. Next, we're going to talk about array indexing. There are two indexing methods. One is slicing, and the other one is integer indexing. First, let's create an array. You can type in this one, or you can use the easier way. Then 3x4 and parent a. Split the cell here. Oh, sorry. So this way it's much easier to create an array. And then we want to get to the those 2, 3, 6, 7. We can use a column 2. This means the first 2 rows, and the 1 column 3. That will give us the second and the third column. And if we want to get to just the first 2 rows, we can write column 2 and then just a column. And we can actually do this without specifying the second axis. Oh yeah, for reshape, there is a little tip. If you are not very good at maths like me, you can specify the first dimension, but leave a -1. So this method will calculate the value for the second dimension automatically. So, yeah. Slicing in Numpy will create a view of the original array. If you modify any value in that slice, it will also reflect in the original original array. So be careful about this one. It can create some problems sometimes. First, let's say, let's create a slice. So, and change the value of first row and first column to 77. It will change the value in the original array A as well. You can see. Also,
sorry,
yep.
Just a quick reminder that so using -1 at any of the axes is a very useful trick for many applications. So imagine you want to programmatically convert the vector on with the unknown names into a matrix, right? So typically, so you have to specify the exact dimension, right? Yeah. But what if you don't know the name? You don't know how many elements in that array, right? So it's hard to do it programmatically. So in that case, so using the -1 at the axis, that is unknown. So will be a very good trick, right? So you don't have to specify. This is a very useful trick in practice.
Yeah, and there's another way. So like you need to check the shape of the array you want to reshape, and then calculate like the numbers using the shape.
Yeah,
but
it's
that's an extra step.
Yeah, that's an extra step.
There's also the rank change. So the rank, as I said before, is the number of dimensions. If you use integer indexing, it will reduce the rank of the array. For example, let's create an array here. 1, 12, and 3 by 4. Again, if you want to use an easier way, just use Numpy arrange 1 to 13. So actually, we'll just go from 1 to 12, and the step is 1, and it reshaped into 3 rows, and it will calculate the number of columns. Let's create this one and print it out. And see, if we want to get the the second row of this array, we can type in just 1 and then column. This means the second row of all the columns. Or we can do A1 column 2. That means 1 larger or equal than 1, but less than 2. So that labels us just 1 and column. Or we can give it a list of the rows that we want. Here we just want the second row, so we type in 1. They all give us similar result, but the rank is different. The first method will give us a 1D array, and the second and third one will give us a 2D. So be careful about choosing the indexing method. And similar for the columns, if we want the second column of the original array here, we can use A colon, then comma 1, or using slicing. So the first one, if we use integer indexing, it will return a rank 1 array. And if we use the slicing, it will return a rank 2 array. And we can choose multiple elements from the original array, like using the coordinate type of. First, let's create the array here. So we created a 3x2 array, and we can access to the first one. If we want the first element, the fourth one, and the fifth one, we can write in 0, 0, which is the first column and the first row, and then second row and second column, and the third row and the first column. It will return 145. Or you can choose the elements one by one, like 0, 0, 1, 1, and 2, 0. But using this way is much easier and efficient. And we can actually reuse some of the values, meaning we can choose the same element multiple times. Say, we can choose the first element twice. We get 1451. And this way, if we use a list of the coordinates of the element, we can make some changes very quickly. See, first we create this this array, this 4x3 array, and we then specify the indices of the element that we want to change. For example, here we want to change the first element, and the third column of the second row, and and the first column of the third row, and the second element of the last row. We can create these indices first, and then specify the indexes using this way. So Numpy arrange will create array from 0 to 3, and B is the indices of the columns that we want, and it will return the list of the elements that we want. So 1, 6 is the third column of second row, and 7, first one of the third row, 11, the second element of the last row. And we can change multiple elements at the same time using this way. So this is the same as before, and plus equal, meaning it will add 10 to each of the elements that we selected. And the Boolean array indexing. So sometimes we want to choose the element based on certain conditions. That's called the Boolean array indexing. For example, here we create this array first. It's a 3x2 array from 1 to 6, and we want to choose all the elements larger than 2. We can first create this Boolean index. It will return an array. Basically, it's so the first 2 elements is not larger than 2, so it are false and false. And the last 4 elements are all larger than 2, so it returns true. And then we can pass these indices to the original array. It will select all the values that has true in there. So we get a return of all the elements in that original array larger than 2. Or we can do this in one step, just a larger than 2. It will return that array with the false and true, and pass this one to the index, and it will return the same result. This can be very useful. For example, if we have a list, if we have a data set of all the temperatures, and we want to see all the temperature that is lower than 0, then we can use this way. Data types. So arrays support multiple data types. It can be integer, float, and string. Normally, you don't need to specify the data type when you create the array. For example, here for x, you just need to pass the list to this function, and Numpy will choose the appropriate data type based on the data. And this one for x, it will create an array with the integer. And for y, if we pass in 1.0, 2.0, it will create an array with the float. And we can specify the data type we want, and it will create the array that we want. So this D type means data type. This is a method that can show the data type of that array. If we change this to float, so basically it will convert all the integers to float. So it doesn't change the values. It will add decimal point to it. And if we convert an array with the array of floats to integer, it will create some problems here. Say Numpy array 1.5, 1.4, 1.5, and 2.8, and then E type, that's Numpy integer. So the decimal point will be abandoned in this situation. Yeah. So array maths. There are many built-in functions and methods that can apply to the arrays. First, let's create those two x and y arrays. X is a 2 by 2 array, value from 1 to 4, and y is 2 by 2 array, value from 5 to 8. We can conduct element-wise summation using the plus sign, or we can use the built-in Numpy add function. Those two methods will return the same result. This is one of the advantage of Numpy array. Using list, you cannot do element-wise operations conveniently. For example, let's create two list and compare. And if we print x list plus y list, it will not conduct element-wise summation, but instead it will just join those two lists. So for a list, if you want to conduct element-wise operations, you have to use for loop. So it's much more convenient to use NumPy arrays. Similar for minus. So basically we'll conduct the subtraction from element-wise subtraction. And there is a same NumPy function for this purpose. And element-wise product, there is a function called multiply. And division, same thing. We have a function called NumPy divide. And there are many more built-in functions to conduct element-wise operations. For example, square root, NumPy sqrt means NumPy square root will conduct element-wise square root operation for each element. And dot production. So this is more about linear algebra. If we create those 4 arrays first, X and Y are both 2 by 2 arrays, and V and W are just a 1D array. Let's just print those. So we can use the method. So basically, you specify the array you want to conduct on, and then dot. This dot is the dot product, and this is the second array you want to use. Or you can use the NumPy dot function and give the 2 arrays you want to conduct the dot product on. And both the method will return the same result. Okay. So let's move on to this sum function. So there are many functions to conduct quick statistical analysis. For example, the sum, the mean, the standard deviation, and so on. Let's see how sum works. If you just specify the array, it will return the summation of all the elements in that array. And we can also specify the axis that we want to sum. If we specify axis to be 0, it will compute the sum of each column. If we specify the axis to be 1, then we get the summation of each row. So here, the first one we specify is 0, we get 4 and 6. That's 1 plus 3 and 2 plus 6. If we change to 1, we get 3 and 7, which is 1 plus 2 and 3 plus 4. And for the mean value, same thing. If you don't specify the axis, it will conduct the mean. It will return the mean of all the elements. And we can also specify the axis to get the mean values. For example, if we specify it to be 0, then we get the mean of each column. And the row, we can specify axis to be just 1. And transpose. We can use dot T to transpose matrix. So in this case, the original array is 1, 2, 3, 4, and the transpose of the original matrix will be 1, 3, 2, 4. If it's an array with the rank higher than 3, you also need to specify the axis. And now let's talk about the broadcasting. So when we use Numpy array, we can conduct operations on 2 arrays of different size. This is a very convenient feature of Numpy. So first, let's create 2 arrays. The first one is 4 by 3. The second one is just 3. And create a empty array with the same shape for x, and we want to add the v vector to each row of the x array. Intuitively, we can use a for loop. So here we have 4 rows for x, because the shape is 4 by 3. And for each row of y, first we get the that same row of x, and then add v to this row, and running this, we get the result that we want. So basically, the first one is 1, 2, 3 plus 1, 0, 1. We get 2, 2, 4. Or we can stack v vector vertically to create an array of the same shape as x. The function is tile, so this is the array we want to stack, and we want to get 4 rows of v, just 1 column of v. So that using this function, we can create an array of shape 4 by 3, and we can just use the element-wise summation that we talked a few minutes before. And the result is the same as the for loop. If we are conducting this kind of operation on very large array, using for loop will take much longer. And in the last, we are using the broadcasting feature of Numpy. We can just add x with v. Although they have different shape, x has shape of 4 by 3, and v is just 3. Numpy will automatically change the shape of v to the same as to the shape of x, and give us the same result we want. So there are some rules of broadcasting. I will not go into the details. If you are interested, you can look into the document. But just want to show you some examples. For example, here, let's create a V of shape 3 and W of shape 2. If we want to compute the outer product, we need to reshape V to be a column vector. And we can use a Numpy reshape function to reshape V to 3 by 1, and then conduct the outer product. And we can also add just a single value to an array. For example, here we first create an array of shape 2 by 5, and if we want to add 5 to each of the element, we can just use +5, and NumPy will broadcast this single value to the same shape as the array we want to add to, and conduct element-wise summation. Last, I want to talk about NumPy file input and output. Sometimes if we are working on a very large project, we want to save the array for other use. So just for later, we can save the array to a file. So here we create the array first, then it's a vector of 20 elements. Then we can use NumPy save function, specify the name of the file. The extension is npy NumPy, and this is the array that we want to save. And to load that array that we saved, you can use NumPy load function, and it will return the array that we saved. We can also save multiple arrays at the same time. So first, let's create 2 arrays. This one is array of a vector of 20 elements, and this one we create a random array with ranging from 0 to 20, and we can use NumPy save z and specify the name of the array. And when we load this kind of a file, we can specify which array that we want to use. So NumPy load, and pass this result to archive, and use the name that we specified when we save that file. So here, this is B, and can get A. And last, if it's very large, array, we can compress it to save some space. The function is save z and compressed. And in the same way, we can save or load. Okay, that concludes my tutorial.
Okay, thank you very much. Yeah.
Sorry, I want to interrupt a little bit. Just highlight one thing here. So when we use like the NumPy aggregate function here, when we specify the axis, I don't know whether you guys noticed that the axis is kind of like reversed on the opposite side to the column and rows we used to have. So this is a little bit different than the pandas axis. So for the pandas axis, 0 means the column, but here it means the zero means the rows, and here it means column. It's not. It doesn't actually mean the column. It's like when you try to do the mean, it actually try to compress across all the rows. So it actually summarize or do the sum or do the mean along each kind of like row and to compress into a column. So this is the huge difference between NumPy and pandas. So it's totally like different. So because later on when we use like machine learning models, like when you calculate the scores, you already will have many cross validation, like 10 folds over there. You're probably gonna have 10 over 10 times 10 like matrix over there. Then you have to know which dimension you want to summarize or which dimension you want to calculate the mean over there. So I just want to say like try not to actually screw up between the dimensions here, because zero means like you try to summarize across all the rows, but here it is a little bit different. Yeah,
thanks. I found this very confusing. Every time I have to try it.
Yeah, same as me, pretty much. Yeah, thanks for bringing that up, because I actually had a question before for the shape as well, because I was pretty much, because I'm more familiar with pandas right now, I was probably trying to use my pandas concept applied back to the NumPy editor sometimes.
Yeah, I don't personally, I don't suggest like, just recognize like a dimension as a column or rows. Just think about the first dimension, second dimension, that's it. Because sometimes you have more than three or more than one, like a 2 by 2 or 3 by 4. In that way, it's really hard to think about every number into like column or rows. So I usually just think about it in the first dimension, second dimension, that's it. Yeah.
Any other comments or questions?
Just have a question about reshape. So when you reshape, what does the -1 exactly mean in the reshape?
I mean, so we don't know yet. So the exact number of on that axis.
Like you only know the first dimension, you only know the second dimension.
Yeah.
It will automatically calculate
So
the second
you
dimension.
do it for yourself, right?
Yeah.
So I was still a question. So let's say we already have the pandas, but why do we want to use NumPy?
Yeah.
There are some
I think
functions.
it's faster to use. NumPy.
It's faster, and yeah, so that's one of the reasons. What else reason you can think of? Because it seems redundant, right? So people already have the pandas, and from the data analytics point of view, so pandas is much easier to use. You can, so do.
The data frame is more user friendly.
Yeah,
It's more user friendly.
Yeah, that's why I want to bring up again. Pandas is more like in a matrix, right? But again, it could be faster. I heard like a NumPy is faster. But again, I definitely prefer to use pandas myself.
Yeah.
And also, again, you mentioned that it would be a lot more user friendly. So in Jupyter, if you have like a much bigger data set, you can always like, for example, with the first row, and then it's always like in like a column and rows like view. So it's just like much easier to even, I would say, scan through your data using like a pandas as opposed to NumPy. Because if you only read your data in NumPy, you need to figure out sometimes, okay, what's what, because it doesn't necessarily in like
The
a very
indexing
specific.
You can
column.
specify like the name of the index.
Yeah, you need to read like a different columns and stuff.
That's a very useful feature.
Yeah.
I would say it's like sometimes like you use pandas just because you have the data frame, but NumPy is not for data frame. So when you don't have the data frame, suppose you calculate the scores, like the accuracy scores. You don't want to put into like a data frame, right? You just want to put it into a list, or
like
when you calculate the means, it's just one number. If it's just like a number or a vector, what's the point of like making them into the data frame?
Yeah.
So it's just for different purpose. NumPy is for more like for like low dimension, like like a summary statistics.
Yeah, like 1D
data. Like for the machine learning models, but data frame is more like for the big picture, like the data frame, like a larger dimension, like a matrix over there. Yeah.
So to me, so the major reason we still want to use NumPy was because NumPy is basically from linear algebra. So you can just think, so you can use it only for linear algebra. So I guess that's the major purpose. And why it's important? So think about it. So let's say if we take a look at the very simple model like a linear regression, right? So it's formed. The equation is like, so you have many coefficients, you have many features, and you will have many coefficients, and you want to multiply the coefficient with the features. So it would be very tedious to write it in W1 multiply Wx x and plus W2 multiplied by x2, etc., etc. Right? Let alone so that not to mention the efficiency to run this kind of operation is very expensive. So it's very if we are going to use pandas to do that kind of work, it will be very, very slow. And the Numpy is specifically designed for linear algebra operation. So using that kind of thing to calculate for machine learning algorithm, linear regression will be much faster and much efficient. So that's the major purpose. So people are still using Numpy. But I've seen less Numpy being used in actual data analytics in very few applications. But most likely, so you would want to use Numpy for machine learning algorithms. So that's just in my experience. So that this is a major reason and the major criteria to decide in which occasion I want to use Numpy in which occasions I want to use.
Are some Numpy's aggregate function more user-friendly than pandas?
Yeah.
Right. I think that's another, like for me, at least that's another reason why I use Numpy, because you can just do the mean, the sum, the argmax,
along the
along the axis. You don't have to put into the the data frame. You can just do those kind of aggregate functions out there.
Yeah. True. And if we want to, let's say, if we want to randomly sample some data from pandas, so one of the tricks I use a lot is just to create an array and with a random, so number, right? And you're using that for indexing the pandas with the data frame. That's another trick.
Yeah. Okay. Any other comments?
I tried to click on one of the link. So I think it's actually on scipy.org respect to the broadcasting. So I use broadcasting doc. It doesn't seem the link is no longer working.
Oh, okay. Yeah, we'll fix that and send you.
Okay, sounds good.
Can you comment? Can you guys comment on the broadcasting?
Do you use broadcast very often?
I think broadcasting is quite intuitive.
Yeah.
To me, I don't even spend how long I'm thinking, so the mechanics, I just use it. Yeah. And so, to me, it's like, so you copy, if we apply addition between an arrow and a scale right? So I would just imagine, so Numpy is going to copy the scalar and the same format for the dimension of the array and just do the multiplication. So
I think for me, it's more like a dimension matching. Like sometimes,
yeah, exactly.
Right? It's just broadcasting is more like I use it like several times, like not very often, but most of the time it's just for the dimension matching, because sometimes you need to match the dimension and copy the same rows or the columns in so that you can match the dimension and do the calculations over there.
I think that's pretty much it for today. Thank you very much for attending.
Good job.
Thanks.
And next week it will be pandas. The topic will be pandas. We
It's
can
gonna be
compare.
much more exciting.
We should be doing it in the Zoom.
Just doing Zoom.
Oh,
Pandas.
very pandas in this. Mhm.
It's a cold joke.
Yeah, sorry.